All right, today we'll talk about vectors called unit vectors. They have a length of 1 unit. Velocity vector, we've already mentioned those, and vector equations. So how could we represent the motion of a car traveling 45 miles per hour west using a vector? And that would just be, we're going to go west, and the magnitude of the vector has to be 45. The length of the vector or magnitude is 45. So we could say that the velocity vector is negative 45, 0 miles per hour. And just because moving left is negative, we have to put a negative there. All right, and do the same thing with a car traveling north at 60 miles per hour. All right, draw the graph and write the vector. North, the length is 60. So when we find the components, horizontally we move 0, and then vertically is 60. It's positive. If it were south, then it would be a negative miles per hour. All right, next is unit vectors, and then we'll go back to velocity vectors. All right, is this vector a unit vector? Well, a unit vector just has a magnitude of 1. We can see that this is going to be longer than that. But to test it, we just find the magnitude. 36 plus 4, 40. So that's not equal to 1. So 6, the vector 6, 2 is not a unit vector. So if the magnitude is 1, then it's called a unit vector. All right, pause the video and try that one. Remember that this form of a vector, you could write it as a column vector if you want. Pause the video and try that. All we need to do is see if the magnitude is 1. And that's going to be 2 over 4 plus 2 over 4. And that equals 4 over 4. So we see that it is a unit vector because its magnitude is 1. Now we'll use unit vectors to find velocity vectors, and that's going to be So here we have a magnitude and a direction. When we make this velocity vector of the velocity of the car, the length of the vector has to be 50 units. So what we're going to do is find a unit vector for this and then multiply by 50, and that'll make a velocity vector. This is also called a scalar. A number that's not a vector, it doesn't have direction, is called a scalar, and that's a vector. All right. So we are going to find the unit vector of this. A unit vector is going to be the given vector divided by its magnitude. So this will be 9 plus 16 is 25. So we get 3 over 5, 4 over 5. The unit vector is a vector divided by its own length or magnitude. So here, this has a magnitude of 1, and it's in the same direction as this vector. So now the velocity vector is just going to be 50 times that. And that'll be in miles per hour. So we have reduce the 5 and we'll get 30. Reduce the 5 to get a 10, we'll get 40 miles per hour. And if we look at what's happening in a graph, we start with this vector. That's 3, 4. And then we shortened it to a length of 1, which was, that was 3/5. So we went 3/5 and 4/5. So we took this vector, divided it by 5, and now we have a short vector, and then we multiplied that by 50, and now we should have something with a length of 50. All right, same problem. We have to find a unit vector and then find the velocity vector. This h to the negative 1 means it's kilometers per hour. All right, pause the video and try that. We need a unit vector in this direction, so the unit vector is the vector divided by its magnitude. So that's going to be 12 squared plus negative 5 squared, square root. 144 plus 25, 169. And that's 13, so we get 12 over 13, negative 5 over 13. And there's the unit vector. Then we just have to multiply it by 650. The velocity vector is 650 times the unit vector. And that reduces to 600, negative 250 kilometers per hour. Okay, now we do the vector equation of a line. All right. So it's starting at 3, 2. And it's traveling 3 to the right, 5 down feet every second. So after 1 second, it's going to be at 1, 2, 3. And then 1, 2, 3, 4, 5. It will be right there. After 1 second. That's the position after 1 second. Then after 2 seconds, we're going to go another 1, 2, 3. 1, 2, 3, 4, 5. And that's its position after 2 seconds. And let's think about this. It starts here, and then so we could just continue this for however long it travels, and we can find its position after some amount of time. And we could even use fractions of seconds. We could say after a half second, then after 1/2 of a second it would be right there, because we go half of 3 and half of 5 down. We could find out at any time where it's going to be along its path. So what we're doing is the position after 1 second is its starting position plus 1 times its velocity vector. After 2 seconds, it's the starting position plus 2 times its velocity vector. When we add vectors, we're just going to add 1 of these after 1 second, but we'll add 2 of these after 2 seconds. So we can see that after any amount of time, we have the starting position plus t 3 negative 5. And so that's going to be the equation of its position. We could say any position xy is going to be its start plus some multiple of its velocity vector. This t is called a parameter. T is the parameter. Common parameter variables are t. This letter is mu, lambda, p, S, Q. So these are some common letters used for parameters. And we're just going to have any point on the path is equal to the start plus some multiple of the velocity. Okay, find the position equation. Well, that's what we just found. Sometimes it's called displacement time equation of a car. All right. So we want any location of the car is going to be its starting location. That's a position vector plus a multiple of the velocity vector. And we're done because it said find the position equation, and there it is. The same strategy is used in a differently worded question. So we have a direction and a starting point. So pause the video and try writing this equation. Starting point and a multiple of the direction. So this will take us, by multiplying by all fractions of, by all real numbers, we can get to any point along the line. All right. So we have a point. We have 2 points. So that's the first step in writing the vector equation of the line. Now we need a direction. So we could say that the direction vector is the vector from one point to the other point. There's that point. There's that point. We're going to have a line going through the points, and we need to have the direction. It could be from this point to that point, or the other direction. It won't matter. So let's go ahead and say it's from this point to that point. So we saw 2 days ago how when you subtract the vectors, that's how you get the vector from one point to the other. So if I want to go from 3, 1 to negative 2, 2, I have to go negative 2, 2 minus 3, 1. We could have switched the order and it would still give us the same same equation of the line. It would give us an equation of the same line, but the equation would look different. So we have any point on the line is the starting point plus, I'll just use a different parameter so we get used to it. This could be a T or some other letter. We're going to start here and then go some multiple of the direction. And it said find the value of lambda when this is the point on the line. So we would do negative 7, 3. And we can just say that all the x values have to be equal 3 plus negative 5 lambda minus 3. So lambda is 2. It needs to work in the y equations also, or the y equation. Minus 1 lambda equals 2. Okay, same question. All right, so pause the video and do the same thing. Find the equation of the line and also find the parameter. The direction vector, let's do 6, 1 minus 2, negative 4. If you did the other opposite direction, you'll get all the same line. It'll just have a different sign. Okay, 6 minus 2, 1 plus 4. We need a starting point, 2, negative 4. We could also use that point. It doesn't matter. So any point on the line is a starting point, or a point on the line, plus a multiple of the direction. We want to know what is t when at this point, at negative 2, negative 9. So we have negative 2 equals 2 plus 4t. Negative 9 equals negative 4 plus 5t. Subtract negative 1. And here we're going to add. So the value of the parameter at that point is negative 1. And that's the end of this lesson.